Okay guys, so this is lesson 3 for unit 5, converting between moles and grams. Your objectives for this lesson will be to learn how to apply stoichiometry to convert moles to grams and then grams back to moles. So I want to tell you guys a little joke, and maybe you will or will not get this at first, just a little chemistry joke. But what do you call a tooth in a glass of water? Okay, the answer, a 1 molar solution. Get it? In water, molar tooth. Ha 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 ha. Oh gosh, I cracked myself up. Anyway, so let's start with a warm-up. Go to your warm-up page on page 2 in your notes. The date, January 7th. Obviously for you guys, it will be the 8th at this point since we had another snow day. The question is, which species contains the greatest percent by mass of oxygen? So this question is very similar to the one that I ended with in your last lesson video, but there was a typo and it said mass of hydrogen, which remember I said the answer had to be B because there's no hydrogen in any of the other compounds. But the actual question is greatest percent by mass of oxygen, since they all have oxygen. So what you need to do here is go back in for each one of these examples and calculate the percent by mass of oxygen for each compound. Okay, so what you need to do is pause the video here, calculate your percentages, and figure out which one has the highest oxygen percentage by mass. Okay, so the answer is B. Oxygen is 88.9% by mass in a water molecule. So after you do your calculations, you will see that the percent by mass of oxygen in H2O is 88.9%. Okay, so remember the allimole. Oh, love the mole. Anyway, there's our 6.02 times 10 to the 23rd. Notice there's no units because it's an arbitrary number, just like a dozen equals 12. A mole is equal to this number. So the application of the mole, the math of chemistry, we will need to convert from grams to moles and vice versa for this class. So the diagram below shows and summarizes these processes. Very easy. If you have mass in grams, it's given to you. Then we divide by the GFM. So the GFM, guys, we learned how to do in the previous 2 lessons. Gram formula mass is grams. And now since we know that it's how many grams are in each mole, we're going to say that the unit is grams per mole, okay, for the GFM. That will give us the number of moles. And then to go from moles to grams, if we have moles in our question and they want to know what the mass is in grams, then we multiply by the GFM. So in any case, or in every case, I should say, we need to figure out the GFM of whatever compound they're talking about or molecule in the question. So converting grams to moles. There's not a lot of notes to take for this lesson, but more of me explaining things to you and then doing a lot of practice problems. So from table T, you're going to use the mole calculations formula. Number of moles is equal to the given mass, which would be the mass in the question. Okay, or in the equation. So given in the question. Okay, and again the GFM, and then this is going to be in grams per mole. All right, because the GFM does tell us formula mass is just in AMUs, and then our gram formula mass, grams, and that's how many grams are in a mole of whatever it is in that compound. All right, so how many moles are in 4.75 grams of sodium hydroxide? So when we're going from moles to grams, then we have to multiply. All right, so first we need to calculate the GFM for the compound, and we have 1 sodium, all right, and in parentheses they gave us the formula, but in some cases they might just give us the name, and we have to use our knowledge of naming rules to figure out the formula for ourselves. So in this one, it's going to be fairly simple. So they tell us, or the question is how many moles. So this is the unknown here. And that's what we're solving for. Unknown with 2 N's, right? And then they give us the mass. Okay, so we're using this equation up here, and we're going to calculate the GFM. So we'll have those parts, and then we just calculate for the moles. So I'm sorry, I said multiply before. We're actually dividing in this case. Sodium, all right, so the mass of sodium is 22.98977. Okay, so there's only one of those, so this is going to be easy, and actually there's only one of everything, so we don't have to do any multiplication here. Oxygen, again, 15.9994. So the total on that is 9994. And then hydrogen is 1 point, oops, sorry about that. Okay, and so we have 4.75 grams of sodium hydroxide. So continuing, I'm sorry about that little freeze on my computer. Hydrogen is 1.000794. And we're going to line this up, 0.000794. And our total is going to be 39.99711. And then remember, it's going to be grams per mole now for the GFM. Step 2, then we're going to plug in the given value and the GFM into the mole calculations formula to solve for the number of moles. So our given mass, again, 4.75 grams. So we always use what's given to us. We have to read the question. And then the GFM, just 39.99711 grams per mole. Notice when we divide, the grams are going to be canceled out and we end up with number of moles. So our final answer is going to be 0.119, or we can put that in scientific notation, which is 1.19 times 10 to the negative 1 moles. Okay? Now again, if you guys write out moles, it's fine, but we're going to get into the habit of using the abbreviation here. So it's 0.119. I rounded to the least number of sig figs, okay, when you're dividing. So there's 3 in the top here, so that's the least number. My answer has to have 3 sig figs. All right, so let's do some practice. How many moles? So this is what we are looking for, okay? So that's the X, or the unknown. And we are given the mass. And here's our formula. Lithium fluoride. So we need to find the GFM of this. Lithium has a mass of 6.94 grams, and fluorine has a mass of 18.998 grams. We're going to add that up to give us our GFM. So that is 25.938. And then we're just going to plug this in. So I'm not worried about sig figs right now. But let's go plug this into our formula from table T. So our number of moles is equal to our mass, 39.0 grams, divided by 25.938 grams per mole. All right, so I'm going to add this in here so you guys can see where I got this from. And this is grams per mole here. All right. Once we divide that out, we will get 1.50 moles of lithium fluoride. All right, so why don't you take a minute, try to do this one on your own, and then we'll come back and see how you do. All right, so as I set this up, I have the number of moles equals the mass that is given, which is this, divided by the GFM of potassium chloride. Now they give us the name, so we have to go in and say, how am I going to figure out this formula? Remember, potassium is a +1, chlorine is a -1. They cancel each other out, so the formula is KCl. All right, so potassium, mass 39.098 grams per mole. Chlorine, 35.45 grams per mole. I add that up. I get my GFM, and then I plug that into the equation. And that's going to be the denominator here, 74.55. Now, when we divide, remember, least number of sig figs, so that would be 3. So our answer has to be rounded to the third place here, which would end up as 1.99 moles of KCl. Number 3, so again, pause the video, try to do this yourself, and then you can check as we go. So remember, it says how many moles, so it's still going to be the same setup, number of moles equals the mass that's given, which is going to be this, over the GFM of KOH. So you need to calculate that. So K, potassium, again, is 39.098. And then again, since we're doing GFM, we're going to just keep grams per mole. And then the oxygen is 15.9994 grams per mole. And our hydrogen is 1.000794 grams per mole. We're going to add those up, and we will get 56.105 grams per mole. I did round to sig figs here. And then we're going to go back, plug in everything. So our mass that's given is 168 grams divided by this number down here, 56.105 grams per mole. Remember, grams will get canceled out. Plug this into our calculators, and we will get 2.99 moles of KOH. Okay, so now we're going to go backwards, and so we do the opposite operation. Since we just divided to get our moles, now we have to multiply to get to grams. So from table T, you're going to use the same formula, but you must rearrange it since you are solving for grams now. All right, so this now, you just rearrange the formula now, so you'll get your mass of your sample, which we are solving for. That's your X, is going to equal the number of moles times the GFM. So like I said, we're always going to have to figure out the GFM. So here's your problem. You're given the number of moles. You have a 2.50 mole sample of sulfuric acid. What is the mass of your sample in grams? They give us the formula, so we have to use that formula to help us calculate the GFM. So hydrogen, there's two of those, and each one is 1.00794. Oh, I think I put too many zeros in the last one, but I think you guys understand what I did there. 0.1588. And then one sulfur at 32.06 grams per mole, and then there's only one, so it'll stay at that. And then 4 oxygens times its mass will give us 63.9976. Add those up, and to sig figs, we'll have 98.07 grams per mole for our GFM. Then what we're going to do is plug in the given value and the GFM into the mole calculations formula and solve for the mass of the sample. Now, you don't always have to rearrange the formula. You can leave it the way it is and just do your algebraic solution for it. All right, so here we have the mass of the sample in grams equals number of moles. So what did they tell us before? We have 2.50 moles, so we're going to put that here, 2.50 moles, times the GFM, 98.07 grams per mole, is going to equal 245.175. But, okay, this is where sig figs is pretty important. We have 3 sig figs here, and we have 4 here. So our answer can only be rounded to 3 sig figs, so we're going to stop here. So we're going to say our final answer is 245 grams. That's the mass of the sample in that many moles. So you need 245 grams of sulfuric acid to equal 2.5 moles of that solution. Okay? So let's do some practice. What is the mass of 4.5 moles of KOH? So first we're going to say, all right, we know we have to solve for the mass. What is the mass? So that's going to be equal to X. And then we have the moles times the GFM of KOH. Okay, so we know what the moles are, 4.5 mole times, and then we have to figure this one out to give us the mass, or X. Okay. So let's figure out KOH. Actually, we have already calculated in a previous example. So KOH from number 3 in previous example, I'm not going to recalculate it. You can go back and do it. Is actually equal to 56.105. grams per mole. When we multiply that out, we are going to get 252.4725. Look at our sig figs. We have 2 sig figs here, 1, 2, and here we have 5. So our answer can only be rounded to 2 sig figs. So that would stop here. So how are we going to round this to make sure? Well, it's at the tens place, so that's going to be 250. Okay, with no decimal. If I put a decimal, it makes it 3 sig figs. So there's 2 sig figs, 250 grams. Okay, so we only have a couple more practice problems and we're finished with this lesson. So what is the mass of 0.50 moles of copper sulfate? Give yourself a few minutes to try to calculate this, and then I will pull down the screen to show you how to do this. Okay, so pause the video and then play when you're ready. Okay, so the mass equals moles times GFM, 0.5 moles, which is given to us, times 159.60 grams per mole. And where did I get that from? Obviously, here's my other work over here to figure out the GFM of copper sulfate. Copper sulfate, SO4, if you guys remember. So a lot of this stuff, you know, you have to bring back, and that's why I said it was really important not to forget what happens in other units. All right, so when I plug all of that into my calculator, I get 80 grams of copper sulfate. Please check your math. Number 3, what is the mass of 1.5 moles of nitrogen gas? Now, remember, nitrogen by itself, it's part of Brinkelhoff, so it has to be N2. It's diatomic. Okay, so the formula for nitrogen gas is N2. Again, pause the video now, and then press play when you're ready to check your answer. So first, calculate their GFM of N2, which you should get 28.014 grams per mole. And then to calculate for the mass, we would just simply multiply that GFM by the number of moles that is given to us in the question, which is 1.50. And with sig figs, remember, you have to look at the sig figs. If you don't remember how to do sig figs, please go back to that lesson. I believe it was in Unit 1, okay, on sig figs. When we multiply, it's rounding to the least number of sig figs. So that would be, in this case, 3. So this would be 42.0 grams, okay, of N2. So your final answer would be 42.0 grams. All right, and the last question here, what is the total mass of 0.75 moles of SO2? Pause the video, try to do this one on your own, and check your answer when you're done. Okay, so check your math here. GFM for SO2 is going to equal 64.06 grams per mole. Plug that into our formula. 0.75 moles is given to us. Multiply that by that GFM to get 48 grams of SO2. So to conclude this lesson, I want you to do a few practice problems on your own in your homework packets. And remember, you have an unannounced quiz covering the first 3 lessons in the very near future. But obviously, I can't tell you when.